Okay, so up to this point, we looked at the how we figure out the MAC addresses of the routers and the switches with either the show interface command on the routers, or we could look at the show ARP, which is going to show the association between someone's IP address and their layer 2 MAC address, where again IP addressing is at layer 3 of OSI, MAC address is at layer 2. And then the switch, we can verify this by looking at the show MAC address table to figure out how it's actually going to send the layer 2 frames between its interfaces. So the next question would then be, how did the switch figure out these were the MAC addresses of the routers to begin with? And it has to do with the end host, which here would be the Windows machine or the router that's connected on the different ports. When we're trying to send our layer 3 packet, which was the ping, in order to do this, router 1 knows that for whatever device it's trying to send traffic to, since this is an Ethernet link that it's using, all of the Ethernet headers, or the layer 2 encapsulation for Ethernet, we need to make sure that there's a MAC address inside of that actual header. So router 1 says, I need to figure out what's the association or the IP address to MAC address mapping of the end host that I'm trying to reach. And this is what the address resolution protocol, or the ARP feature of IP does. It's going to ask the remote device, I'm trying to reach you through IP, so tell me what your layer 2 MAC address is. Now when the router sends this out, the destination IP address is going to be the machine that it's trying to reach. So if it's trying to reach the Windows machine at 192.168.0.100, in the layer 3 IP header, the router is going to put that address. But the layer 2 header, for the MAC address, it doesn't yet know what this is. So what it does is set the address to all Fs, where all F's MAC address from layer 2 is what's known as a broadcast. Basically, it's asking the layer 2 switches that when you receive this frame, I want you to send it everywhere, because I don't really know where it's supposed to go yet. So the switch receives the ARP packet, the address resolution protocol. It looks at the destination MAC address and says it's all Fs. It's the layer 2 broadcast. So for every interface except the one that it was received on, so every interface except fast Ethernet 0/1, the switch is going to send this out. And this is what we call the flooding procedure on the switch. So the switch is trying to help the router out to figure out what's the MAC address of the destination. And once the router knows that, the switch implicitly is also going to know the layer 2 MAC address. And the reason why is that when router 1 sends the ARP, if we look at the actual packet format of this, there's 4 fields that we mainly care about. What is the IP source address? What is the IP destination address? What is the layer 2 MAC address source? And what is the layer 2 MAC address destination? Now the router is mainly concerned with these fields, the source and destination IP address. This is what we're going to do layer 3 routing based on. So when we look at our layer 3 routing protocols like RIP or EHRP or OSPF, we're making our decisions on these fields inside of the packet. But the switch is making its decision based on these addresses, the layer 2 switching procedure, the layer 2 MAC addresses. But when router 1 actually builds this frame, it's going to set the layer 3 IP address source to its own address. So it says the source address is 192.168.0.1. The destination address is whoever we're trying to reach. So in the case of the Windows machine here, it's 192.168.0.100. Its MAC address source is going to be the address that router 1 has on its own interface. So if we look at the show interface fast Ethernet 0/1, or excuse me, fast Ethernet 0/0, it is this address. This address here, the 0011BBA4BC20. So we'll say that this is router 1's MAC address. The destination it doesn't know yet, so it sets this to the all Fs address, or the layer 2 broadcast. Now when the switch receives this frame, again, it doesn't care about the information here in the layer 3 header. Only thing it cares about is what's the information in the layer 2 header. But the switch is going to make an assumption now that based on the fact that the packet came in from this source, that should be the same interface that I'm going to use to get back to them. So when router 1 sends this ARP, it's saying that the MAC source is whatever my address is, router 1's MAC. The switch hears this coming in, it looks at the source address, and then it's able to put this address into its CAM table or its MAC address table to say that this is what router 1 was sending the packets from. I now know that this MAC address is reachable out that port, out fast Ethernet 0/1. It doesn't yet know where the destination is, though. It doesn't know where the Windows machine is. So when router 1 sends this request, if we were to ping 192.168.0.100, and actually what I'm going to do as well is we're going to look at a debug command, which is for looking at more detail exactly what's going on with the protocol process. This debug ARP is going to show us router 1 actually asking for the address. So if we debug ARP, and what I also said was clear ARP, which was deleting the old ARP cache, or basically that table when we look at the show IP ARP. What we should see now is that router 1 is going to generate this packet asking what is the address of 192.168.0.100. What is the MAC address of this? And also, to make this a little bit clearer, I'm going to turn off these timestamps so these don't appear in the output. I'll say no service timestamps. I'm just going to turn those off. And let's start this process from the beginning. So I'm going to shut down the interface and then bring it back up. Now, anytime you disable an interface, it's automatically going to reset all of these layer 2 and layer 3 processes. So router 1 knows that it's trying to figure out what's the MAC address for this destination. It says my packet is coming from 192.168.0.1. This is my layer 3 source address. My layer 2 source address is my MAC address. The layer 3 destination is 192.168.0.100, but I don't yet know their MAC address. So I'm going to ask them. I'm going to send this to all Fs. If we send the ping again, ping 192.168.0.100, we should see router 1 generates this request saying, I'm trying to figure out who has this who has this IP address. So tell me the MAC address that's associated with this. This gets to the switch. The switch says it's going everywhere. So I'm going to send it out all of my other ports. I'm going to flood it out every interface that I have. Eventually it gets to the Windows machine because it's connected on that port. The Windows machine looks at the destination IP address and says that's going to me. That's my address, .100. So I'm going to send them a reply telling them what my MAC address is. So the ARP request was coming from router 1 asking what's the layer 2 address of this host. The ARP reply comes in from the Windows machine saying, I have that IP address and I have that MAC address. But based on this bidirectional communication, now the switch learns both of the addresses. So it knew what router 1's source address was, so it places that in the CAM table. It says the MAC address of router 1 goes to port fast Ethernet 0/1. Then I heard the reply come back in from the Windows machine, so the MAC address of the PC is located on fast Ethernet 0/24. And essentially this procedure is going to happen for all communications. So anytime you want to reach someone with IP, if you're running over an Ethernet interface, you have to send this address resolution protocol request. So it's a specific interaction between layer 3 IP and layer 2 Ethernet to do that association of the addresses, the IP address to the MAC address. If you look on the Windows machine, you can see this from the command line. If you say ARP and then give it the argument -A, it says display the current ARP entries. ARP-A shows the, and I need to say for a different interface. How do I say for the interface address? So it actually shows both. The Windows PC, since it has multiple NIC cards, it's maintaining two different ARP caches, or basically copies of the table that are mapping the IP addresses to the MAC address. So it now knows that anytime I send an Ethernet frame that's going towards router 1, I need to put this layer 2 address, or this MAC address, into the Ethernet header. Now this is what I mentioned as before as what's known as the broadcast domain. So devices on an Ethernet LAN that are in the same broadcast domain are able to send these frames to each other that go to the all Fs address. And this is going to allow us to run that address resolution protocol, which is the IP address to MAC address mapping. Now when we look at the case next that we start to subdivide the LAN into virtual LANs or VLANs, those are going to define different broadcast domains. It means that if router 1 is in a separate VLAN than router 2, they won't be able to exchange ARP packets directly, and they won't be able to figure out what are each other's MAC addresses. But we'll see there's a specific reason why we would want to do that.